Hey there, this is Aditya Karatkar and welcome to the Brainstorm Codings. In the last video, I told you about identifiers and keywords in Golang. In this video, I'm going to teach you about the data types we have in Golang. So in Golang, every variable has a data type. So a data type specifies the type of data that a variable holds. So this is the variable we have declared in the last video. We have this channel name variable and it has a value of string, which is brainstorm codings. So as it has the value of string, the data type of this variable is strings. So in Golang we have four categories of data type. The first one is the basic type, which contains numbers, strings and boolean data types, and this is the category we are going to see in this video. Second one is known as aggregate type, which contains arrays, structures. Third one is the reference type, which contains pointers, slices, maps, functions, and channels. And the fourth one and the last one is the interface type. And in this video, we're going to discuss about the basic data types, which are numbers, strings, and the Boolean values. And we will discuss these other three categories later in the course. And I will make videos on arrays, slices, structures, pointers, functions, each one of them separately. But for now, let's talk about numbers, strings, and Boolean values. So let's start with numbers. There are three subcategories in numbers. First, we have integers, and then again, there are two different integers we have. There is a signed integer and an unsigned integer, and they both are available in four different sizes. And these categories and subcategories and different sizes are blowing my mind now. But still, we have to continue with this. So we have four different sizes. We have 8-bit integers, we have 16-bit integers, we have 32-bit and 64-bit integers as well. So let's see how many integer types we have. So we have int 8, which is an 8-bit integer. We even have int 16, which is a 16-bit integer. We have int 32, which is a 32-bit integer, and we have int 64, which is a 64-bit integer. We even have these four sizes for unsigned integers as well. Just the difference is we denote the unsigned integer as uint, as u implies the unsigned. So we have these four sizes in unsigned integers as well. And we can even use int or uint, so we don't need to specify the size, just like uint 8 or int 8. We can even use only uint and int, uh, and int and uint are both 32-bit and 64-bit in size. So they don't come with 8-bit integers and 16-bit integers. If we have mentioned int or uint, then they only come as a 32-bit or 64-bit integer. So let's declare a variable. Let's declare an integer variable. So where number int is the data type we use. Let's assign a value 32, and let's try to access this variable. Num, run the program. And yeah, we have this 32 value, which is held by the variable num, which is an integer variable. And then there is another type of numbers we have. We call it as floating point numbers. Generally, floating point numbers come in two sizes. We have 32-bit and 64-bit floating point numbers. And floating point numbers always come with a decimal. So let me show you how to we use the floating point numbers. Instead of declaring an integer variable, let's declare a floating point number known and give it a data type as float 32. We can even take float 64, but for float 32 is fine. And let's assign it to value as 32.56. As I said, they all come with a decimal for sure. And try to access this variable. Let's see what we get. And we get 32.56. Let's try to access this variable without a decimal. Let's see what we get now. And we are getting 32. So we have to mention this decimal for all the time if you're declaring a floating point variable. And the last type of numbers we have is the complex number. And there are two types of complex numbers we have. One is a 64-bit complex number, and another is a 128-bit complex number. A 64-bit complex number contains a 32-bit floating point number as a real and imaginary component. And 128-bit complex number contains a 64-bit floating point number and an imaginary component. So let me show you how do we use a complex number. So let's declare a complex number variable where a complex 64, which is a 64-bit complex number, assign it a value complex 32 and 4. Alright, so here this 32 is a floating point number we have, which is a 32-bit floating point number, and this is the imaginary part. Let's try to access this variable. Let's see what we get. And we get this 32 plus 4i, which is a complex number, and this 4i here is an imaginary component. And the second category in the basic data types we have is Boolean. The Boolean data type represents only one bit of information. It represents either true or false. And we cannot convert the Boolean values into another data type, as we can do with another data types, like we can convert an integer type value into a floating point number, but we can't do it with the Boolean values. Let's try to create a variable with the Boolean value. The a is a variable we have. Try to access this value. This is undefined true. I think I should use lowercase letters. Why undefined Boolean? Oh, we should use bool. My bad. Alright, so we get here true as the value which is held by this a variable, which is a Boolean variable we have. And the last data type finally we have is strings. The string data type represents a sequence of Unicode code points, or let me get this straight for you. We can say that a string is a sequence of immutable bytes. That means once we have created a string, we can't change it. And you have seen me creating a string variable in the last video, but let me create it again. Channel string. And the name of my channel is obviously Brainstorm Codings. Subscribe to channel please. Print line, and we're accessing this channel variable. And here we get this value Brainstorm Codings, which is a string held by the channel variable. So I think that's all for this video. Thank you so much for watching, and I'll see you in the next one.